Hello, class. We're looking at 5-7 today, and obviously you can tell that I am not with you again. I did get seated for a jury, so it looks like I won't be back until Friday. Please feel free to email me if you have any questions. Please feel free to stop in and try to talk to Mr. Goodman, Ms. Busker, Ms. Clausen. Any of the teachers will be happy to answer any of your questions. The tag room is available, but we'll do the best we can here. So today we're going to be looking at systems of linear inequalities. So the same thing that we did in 5-6 on Monday, we're just going to be doing a system today, okay? So I want you on page 162, go ahead and go down to where it says exploration number 2, and I want you to start on this one because I like this one a little bit better, okay? So what you're gonna do is you're gonna work on the bottom of page 162, part A, and then I want you to go over to page 163 and actually try to go ahead and answer all the questions. So B and then 3 through 6, all right? So go ahead and pause the video here and go ahead and work through that. All right, hopefully you paused it. You should have graphed them. Now, if you don't have two different colors, that's fine. Maybe you just made, one pencil, one pen, something like that, okay? So on this first one here, we're gonna start at our intercept at 4, so hopefully you probably solved this for y. So you went ahead and moved the 2 over, so you solved it for y, so you went down 2 over 1, down 2 over 1, and you noticed it had the bar underneath, so we're gonna go ahead and make that solid. And now notice it says use 2 different colors. Again, if you don't have 2 different colors, that's okay. We're going to go ahead and shade this. So this is the less than region, okay? So it should be shaded right there. So now the second one, you should have also solved this for y. Now just be careful when you solve this for y. Notice when you first move the 2x over, the y is negative. See how there's that subtraction sign? So when you divide off the negative, you're going to have to reverse it, and then it'll become a positive, okay? But remember, you got to flip that sign. So we're going to start at the origin, and then we're going to go up 2 over 1. And if you notice, they do cross at a nice point, but that's really not our main focus. Since it does have the bar underneath, we're going to go ahead and connect it with a nice solid line. And then it says greater than. So since the greater than would be in this region up here. Now, what they want you to notice, or what they want you to see, is over here on part B. It says describe each of the shaded regions of the graph. What does the unshaded region represent? So basically, when these two overlap, so this area right here, where they overlap, that is the solution area, okay? So where the overlap is, that's the solution. The unshaded area is the non-solution, or the things that don't work. So what does the unshaded represent? So it's like maybe the points that don't work. Part C says, how can you graph a system of linear inequalities? What they just want you to think about here was when you're doing linear inequalities or a system, that you're putting them on the same graph, okay? So it just means that you're graphing 2 at a time. So 5-7 is not that much different than 5-6 at all, okay? It says when graphing, we kind of already answered this, when graphing a system of linear inequalities, which region represents the solution? I would probably say the overlap. And again, I wish I was there with you to ask you this, but since I'm not, I'm here by myself, then I have to kind of answer my own question. So this is the solution. So it means if I pick anything in this area, so like let's say I pick the ordered pair -2, 0. If I take this and plug them in, it will work. If I pick a point over here, see how this nobody is shaded? So if I pick 4, 0, it doesn't work in anything, so it works in nothing. What if I pick a point like right here? So what if I pick 1, -4? Notice 1, -4 would work in the first one, but it doesn't work in the second. So it only works in one equation. So basically what they're asking you is what ordered pairs work in both of the inequalities, okay? Sometimes I have a habit of saying equations, but these are inequalities. It says, do you think all systems of linear inequalities have a solution? Now again, I wish I was there to ask you to get your opinion, but the answer is no. Let's say we have parallel lines. Now, it doesn't matter if they're dashed or solid. So let's say we have a line that looks like this, and let's say it's the greater than or equal to, doesn't really matter what the numbers are. Let's say the solution is this way, okay? What happens if we have another line, and it can be dashed or solid, it doesn't really matter. We'll say it looks like that. And so what if it's y is less than? So now the solution goes this way. Notice now, they don't have anything in common, okay? So there are some different ways to draw this. It just, you have to be kind of creative. If you look over here, notice, if we maybe had different ways to shade, we might not even get a solution area as well, like if we had something, over here. So it just kind of depends on how they're drawn. All right, number 6, it says write a system of linear inequalities represented by the graph. Now, hopefully your paper, you can see it a little bit better in your student journal. It kind of doesn't project very well right here. But notice you have, it doesn't matter which one you do first, but this one's vertical. Verticals are always going to be x and then the number. Now, if we're doing an equation, it's x equals, but since we have an inequality, we're going to have to change this. So it's going to be x. Now notice you want all the numbers smaller. So we're going to say less than or equal to, because it has the bar underneath, and then this goes through the point 2. So it's x is less than or equal to 2. Now remember, any horizontal line is always y equals the number. But again, we don't have equations, we have inequalities. So we're going to do y. Now notice the shading is below, okay, and hopefully you can see that it's a little bit darker or more of a grayish area. Hopefully it comes through in your student journal okay. So notice it's got the bar underneath, so we're going to put the bar, and then this one goes through, it looks like at 3. So y is less than or equal to 3. So that would be our system of inequalities. So today's lesson looks a lot like what you did on Monday, where you're going to be graphing, you're going to be telling if it's an ordered pair as a solution, you're going to be graphing, you're going to be looking at writing the equation from the graph, and potentially a story problem. So those are kind of the 4 areas that they're going to go through in the note packet. So if you want to turn to page 164, there's really not much to do. There's some vocabulary here, words here, so if you want to look them up, you can. Remember, system just means that it's 2 or more. So you have 2 or more inequalities together on the same picture. A solution just means it's the ordered pair, so the x comma y, that works in both. So it has to work in both inequalities. And then you know what a graph is, you're just graphing them. So they give you another example here, so you can kind of see, again, the darker area here. See how the one is less than, so it's shaded down, where this one is greater than, so it's shaded up, so their overlap would be in the middle here. So kind of what we're looking today is for the little area. Now, sometimes the area is larger, like for instance, the one we did right here, that's a fairly large area. Sometimes the area will be kind of small, like it was on this page, where that's kind of a small little triangle wedge. So it really just depends on what it's going to look like, okay? So let's turn to page 165. And on page 165, notice they start out with 4 problems here, and it just says, tell whether the ordered pair is a solution. So all we have to do is plug them in. Now notice this first one's a little tricky because there's no x value. So all you're doing is plugging in the y value. So is 0 greater than 2? And the answer is no. So if you get a no, you don't even have to check the second one, okay? So if we go over here, notice when we plug the y in, 1 is less than 3. That is true. So now we have to try the second one. So if we plug the x and the y in, we get 1 is greater than -5, which is true. So we say, yes, this is a solution, okay? So if you want to pause it here and go ahead and try those other two, that would be great. All right, hopefully you tried them. We'll quick work them out. Just in case somebody does have a question and I'm not there to answer it, we'll just quick do them, okay? I promise I'll try to do them fast. So if I plug in, remember, this is my X and this is my Y. So if I plug it in, notice 3 is not greater than or equal to 6. So we say, no, this is not a solution, okay? So this one, we're going to plug the 4. When we plug the 0 in, that just cancels. Now remember, it's one or the other. So 4 is less than or equal to, and that is true, so this one works. Then we're going to plug it into this one. Notice the 0 cancels that out, so 4 is greater than. Remember, it's an or, so we say yes, this does work, okay? So that's part 1. Part 2 is, can you graph them? Okay, so we'll just try a couple of these. Remember, if it doesn't have an X, that's horizontal. If it doesn't have a Y, that's vertical. Now, if you do have 2 different colors, or at least maybe a highlighter or something, it really would be helpful, but it's not mandatory. So y is greater than -2, so we're going to go down to -2, and we're going to do a dashed line because there's no bar underneath, and we're going to do above. And the next one, notice there is no intercept, so we're going to start at the 0, and we're going to go up 3 over 1. Now, I sometimes like to do at least one more just so I get kind of a nice shape of my line, but it kind of goes off, so that's okay. We can kind of ballpark it right there. Now, this is going to be solid. And it does say less than, which is on this side of the line. Remember, we talked about picking a point and plugging it in and trying it. If you don't like the way to shade. Now, because that goes through 0, 0, you can't pick that. You'd have to pick like 2, 0 or 1, 0, or you could even pick 1, 1. You just can't pick something that's on the line. So the area that they overlap, if you kind of look there, is going to be this part. So anything you were to pick in this kind of right corner area would work in both. Anything you pick down here only works in the second. Anything you pick up here only works in the first. And then this is nothing, doesn't work in either, okay? So why don't you go ahead and pause it here. And I believe for just graphing, there's 3 more. So why don't you pause the video here and try those 3. Okay. Hopefully you tried them, and here quick is the answers again. If I was with you, maybe I'd already have these drawn, but I just want to kind of make sure nobody has questions. So y is less than 3, looks like that. X is less than 2, so both of these are dashed. Hopefully you can kind of see that. X is less than would be this way. So this one has kind of a large solution area. Has quite a bit of space here. So please just make sure that I can tell where the solution area is on your paper, okay? All right, number 7, starting down at the intercept, -2, doing my slope, up 1 over 1. This is got a bar underneath, so it's going to be a nice solid line. And we're going to go greater than, so we're going to shade above. All right, the next one is a +2, and we're going to go down 1 and over 1. And it's going to be a dashed line. And it's going to be less than, so it's this way. So, oops, gosh, I hope you could see that. Sorry, I'm not used to this iPad thing. Here's my solution area. Okay? And the final one, of course, they do not give it to you in y equals. So you have a couple options here. We talked about this yesterday. You can use the cover-up method. So we can go 6 divided by 2, which is 3. Then we can cover up this one, and we can go 6 divided by 3, which is 2. Now, the only thing you have to watch for is your shading when you do this, okay? So I'm going to go ahead and connect this. I know it's dashed. Now, right now it's the less than symbol, but sometimes this symbol will change, like it did I believe on one of these other problems when we had to flip it. There was one where we had to flip it, or maybe it was yesterday, and problems are starting to run together. So you just have to be careful. Because this is a positive, it will not flip my sign. So this will be the less than, okay? Now, this one is a little bit harder to do the cover-up method because you see how the x's and the y's are not on the same side. It's almost easier for this one just to go ahead and bring your 1 over. So we'll just rewrite that with the 1 on the other side, and then we'll graph it from there. I could have done the same thing on this one. It just would have been more work, so that's why I use the cover-up method. But you can do it. You can put it in the y-intercept form. So we're going to start at 1. We're going to go down 2 over 1, down 2 over 1, and this is a solid line. And it says greater than, so I'm going to shade it this way. And notice I don't have that large of a solution area, just kind of this little wedge in here. Those are the only numbers that actually work as a solution, okay? So hopefully you're feeling good. We're kind of just rolling right along here. We've got sort of 2 more parts to go. I know you only see 1 more in your student journal, but there's one other thing I just kind of want to touch base on. So on number 9, we have to write the system from the graph. So this is just like what we did in 5-6, only now we have 2 of them, okay? So it doesn't matter which one you do first. I just kind of do the one that grabs my eyes first. So my eyes are going towards this horizontal first, okay? So any horizontal is just Y. It is dashed, if you can tell, and it is shaded down below. It looks like this looks like the dark region here, okay? So shaded down below would be the less than, and we're going through at 3. So it's going to be y is less than 3. This is a vertical line, so we've got x. Notice it is less than. That's why this area is shaded. It's from the x. The x is actually shading this way. You can kind of see some of this is shaded. That's from the y going down. So x going to the left, we want less than, and it looks like it's at a 2, over here at 2, okay? How about I will skip this one for now, and how about I'll do a diagonal with you, and then I'll let you try those 2, okay? So let's try 11 together. So on number 11, it doesn't matter which one you do first. My eyes are kind of grabbing this dashed one. So I'm going to do y. Now I know it's a dashed, and if you look, if this is the solution area, it would have had to have been shaded this way. And you can kind of see a little bit of shading right here. So this one would have been shaded down or less than. Now you need your slope and you need your intercept. Well, my intercept is pretty clear. That's a 1. My slope looks like it's down 1 over 1, down 1 over 1. And this is a negative line. So it's negative x plus 1. This other line here, we know we've got the bar underneath because it's a solid line. And notice the shading is above. So you can see that's why they overlap. So the dashed line was shaded this way. This dark line, solid line, was shaded up. That's how we got the solution area. So we have y is greater than, and notice we still have a slope of 1, but notice this is a positive line, and it's going through at plus 1. Okay? So why don't you guys go ahead and try 10 and 12 for me. All right, hopefully you paused it, and we're looking at both of these. It doesn't matter which one you do first. So the top one would be y is less than 3, because to get this dark area, we would have had to have been going down. Then this one would have been y is greater than 1, because we would be going up. So the top one's going down, the bottom one's going up. So that's why their overlap is this little region down the middle. Okay? All right, number 12. Notice when they kind of have this strip, it's like one is going up and one is going down. They're kind of crisscrossing each other, so that's how we get that region. So I'm going to do this one first. So this would have to be y is less than. We would have to be going down. And then our slope looks like it's -1, and our intercept is +1. So we've got our intercept and then our slope. The other line is a y is greater than because it's going up, okay? Our slope also looks like it's -1. These things are parallel, but we're going through at a -2. So that would be our system. So that wraps up the student journal, but as you guys know, the student journal I don't feel like always does justice for everything that's going to be required of you. So if you have your book handy, I didn't get a chance to print these off because I was really hoping that I was going to be back with you, but of course I did get selected, which will be kind of fun. I'm kind of excited. So on page 277 of your book, if you want to go ahead and get your book out, you're going to need it for your homework anyways. On page 277, there's a story problem, and I know you can see the story problem, the answer, and everything like that, but I just want you to see what it's going to look like as a story problem, because a lot of times in story problems, you don't just have two inequalities. Sometimes you have more. 2 is the minimum to be a system. So when it says write and graph a system, that's a minimum of 2. That means it could be 3 or it could be more. So it says modeling with mathematics, okay? We're on page 277. You have at most 8 hours to spend at the mall and the beach. You want to spend at least 2 hours at the mall and more than 4 hours at the beach. I know you can see the answer, but just think to yourself, okay? You have at most 8 hours. Now, I like to put my variables on the left. I know there's some people in here that don't mind them on the right, but I think it's easier if I keep my variables on the left. So between the mall and the beach, I only have 8 hours. So the most I can be is 8. Now, if you want to put your number on the other side, it's going to look like this, okay? It says you want to spend at least 2 hours at the mall. So the mall, you want to be greater than or equal to 2. Then it says, and more than 4 hours. So the beach has to be more than 4 hours. Notice I didn't put the bar underneath that one, okay? And then it says write and graph a system that represents the situation. So in your guys' homework, obviously it's going to be a worksheet again today, so that way you have some graphs. You will have a graph big enough to go ahead and graph this. So if we look down here, now notice they just used X and Y's. Sometimes I like to use the letters that represent the story problem. That way I don't get confused on which one is which, okay? So notice how they're graphing it. So you're going to want to label your axis, mall, beach, and then do you see how they put the 3 of them on there? So the solution, it's still going to be an area, it's just where do the 3 cross, not just 2 now, it's all 3, okay? So let's try, I wonder to see if they had another example right here. How about this one? I know you don't have it. If you I'll quick cover it up right here. Okay, it says extra example in my book here. It says, so you don't have this one in yours because this is the teacher's edition, okay? You have at most 7 hours to spend playing soccer and swimming. Now that stinks because they're the same beginning letter. So let's just do X and Y this time. So we'll do X plus Y. You have at most 7 hours. So we have to be less than or equal to 7. You want to spend at least 2 hours playing soccer. So soccer, you want to be at least 2 hours, okay? So we'll say soccer is greater than or equal to 2 hours. And then it says, and more than 2 hours swimming. So in a way, they use different words, but they're the same inequality, okay? So we're going to go ahead and write them out. Now, if we had to graph this, I know I don't have perfect graph paper here, but you're going to have X is at 2, so it's going to be going this way. You're going to have y at 2, which is going to be going up. So right now, we know it's in this area. And then notice we have one in standard. The easiest way to do this one is just to use your intercepts. So if we go over here to like 7 and we put a dot, and then we go up to 7 and we put a dot, and then we can connect them. And notice it says less than, so we would be shading this way. Now, it doesn't always work out to be a triangle, but a lot of times it does. So there's your little overlap, okay? And then you can kind of see here, the book has it graphed, a little bit nicer with the axis, okay? Sometimes they'll ask you for an example, like how much time can you spend? All you have to do is kind of look at your graph and then pick a number that works in here. Notice you have to pick numbers bigger than 2. So you could pick 3 and 3, you could pick 3 and 4, but you can't pick 4 and 4 because that wouldn't work, okay? You could pick 2 and 2 because it has to be less than 7. It doesn't have to be equal to, all right? So a lot of what you just did today is exactly the same as that we did on Monday. You just have 2 problems together, okay? So hopefully that wasn't too confusing. Hopefully you don't have a lot of questions. If you do, please ask. Please feel free again to stop in and see the tag room, Mr. Goodman, Miss Busker, Mrs. Clausen. Any of those people will be happy to help you, and I will be back as soon as I can. Help you have a great day.